Hi folks, in today's video, I'm continuing my series on grounding. In my last video, I discussed our body's physiology. The link's at the end of this video. Today, I'll discuss how we protect humans from electrical shock. I'm not going to discuss obvious things like turning off the power or unplugging something before you work on it. I'm going to discuss what manufacturers and designers do to protect you. One commonly used safety device is called a ground fault current interrupter. A ground fault occurs when there is a break in the low resistance grounding path from a tool or electrical system. The electrical current may then take an alternative path to the ground through the user, resulting in serious injury or death. The ground fault circuit interrupter, or GFCI, is a fast-acting circuit breaker designed to shut off electrical power in the event of a ground fault within as little as 25 milliseconds. It works by comparing the amount of current going to and returning from the equipment along the conductors. When the amount going differs from the amount returning by approximately 5 milliamps, the GFCI interrupts the current. You'll remember from my last video on physiology, humans are hurt by current, not voltage, since our skin and tissue resistances are so variable. Also recall 4 milliamps is the level where we feel a shock but are not harmed. The GFCI is rated to trip quickly enough to prevent an electrical incident. If it's properly installed and maintained, this will happen as soon as the faulty tool is plugged in. If the grounding conductor is not intact or of low impedance, the GFCI may not trip until a person provides the path. In this case, the person will receive a shock, but the GFCI should trip so quickly the shock will not be harmful. The GFCI will not protect you from line contact hazards like holding two hot wires or a hot and neutral wire in each hand, or contacting an overhead power line. However, it protects against the most common forms of electrical shock hazard, the ground fault. It also protects against fires, overheating, and destruction of wire insulation. There are several types of GFCI available. There is a breaker type for the breaker panel, so standard electrical outlets can be used. A receptacle type can control several receptacles if wired together. Portable types come in several styles, all designed for easy transport. Some are designed to plug into existing non-GFCI outlets or connect with a cord and plug arrangement. Units approved for outdoor use will be in enclosures suitable for the environment. In addition to GFCIs, designers protect us from touching hazardous voltages in several ways, often called the touch voltage. They do this by enclosing hazardous voltages inside non-conductive housings, like those made of plastic. When metal enclosures are used, there are specific safety guidelines that need to be followed. First, the metal must be hard bonded to a safety ground. Second, any vent holes or openings must not allow a person to touch any of the hazardous voltage. There's even something called an articulating finger to mimic a human's finger. And for smaller holes, there's a disc with a small protrusion. When it's placed through the vent hole, it must not touch any hazardous voltage. Then, of course, safe level low voltages are often used, like those used to recharge our laptops and our cell phones. As always, if you'd like help with anything related to power, please give us a call. We're here to help. Thanks for watching.